Today's clothes washing day. First I need to charge the capacitor up, and then I'll go inside and turn on the washing machine. So keep your eye on the display on that 12.5 volts, 56 watts. When I get up to about 14.5, alright, it's a quick sprint into the house and back out. Washer is just in idle mode. We'll be starting up in a moment. I'll know when the washer started because the voltage will begin to drop. So my wattage is in the lower right corner. It's very low. Because the power is not being used yet. There's a little bit of energy going into the inverter and a little going into the timer on the washing machine, but not much. I can hold it at about 5 watts, and that keeps the voltage constant. So that's about what I'm losing in the inverter right now. The first thing the washer does is fill, and filling doesn't take much power. They're in business. The washer's filling right now. So my target is around 14 volts. Voltage, upper right. Wattage, lower right. And the wash cycle has started. So the fill is over. And it's time to just settle in. To hold the voltage at around 14, looks like I need to put out about 40 watts. It's a very efficient washing machine. It gets a little harder when the machine begins to spin. It's not too hard to control the speed, but you do have to pay attention. More sophisticated electronics would help, but they would also waste energy. So the most efficient way to control the power is to control the power. With this pedal generator, the pedal-powered prime mover, generating 30 or 40 watts is almost too easy. It's a little more work than walking, but not as much as jogging. This lower corner shows total watt hours, 4.5. Got a long way to go for this low to wash. Still averaging around 40-45 watts. This is a front-load washer, and it actually will rotate in one direction and then stop and pause, and rotate in the opposite direction. So the power it requires changes pretty dramatically, depending on whether it's rotating or stopped. Later on in the movie, you'll see what the equipment is that takes care of that. Still holding it around 14. It's dropping a little bit. That's our first spin. We're pumping out and spinning. Filling up again. We're back to agitating. And another spin. Filling. Rinsing. Spinning. Resting. Spinning again. Taking a break. Back way off. It's not raining in here, that's me dripping sweat. Now we're picking up again. Spinning. I can tell by watching the volt speed. $60. Picking up again. Full speed. Resting. And that may be it for the anti-wrinkle cycle, which is just a slow tumble. 41.5 watt hours. That's a push. I'm waiting for the voltage to stabilize. And I think we're done. I'm going to go inside and check the washing machine. We didn't make it. The inverter cut out on the final spin. It was too much for it. So the next step is going to be to try to use a more sophisticated energy storage device. And that would be right here, which has got more capacity than the ultra capacitor that we used. Just so you can see how this is all done, here's a little walking tour. Power comes out of the pedal generator, and it's going through this black wire. On it goes, past the Sparrow electric car, on out here, to the power board. The power board is hooked up to this gigantic 1,000-watt inverter. On goes the cable. Now some of the problem may just be how long these wires are. It's never good. Oh yeah, we're going back, way back. And there it is. Plugged right in. That's my Kenmore washer, which was all set. That's where it stopped. So that was today's experiment, and there will be more.